All right, number 14, we have 8 parts, or there's 4 steps. It wants us to complete the function, or complete the following steps given the function, the interval, and the value of n. So we're going to sketch the graph of the function. We're going to calculate the change in x, the grid points. We're going to illustrate the left and right Riemann sums, determine the Riemann sum underestimate or overestimates the area, and then we're going to calculate the left and right Riemann sum. All right, so this will take quite a bit of work by hand. We're going to use technology to assist us. I've written down everything that we're going to need. So the function, I've written down the domain, n, and from our textbook, toward the very end of the section, it shows how to compute left, right, and midpoint Riemann sums using the summation tool. And so I've written that down here. All right, so the first part is we're going to graph it. And I'll let it graph and restrict everything just as we need. So I'm going to go to y equal, minimize this so I can see the full calculator on the screen. We're going to do cosine, and then we're going to do x minus 3 power 4. So we're going to do x minus 3, and then we have to do second, and then housetop to get pi over 8. I think I said over 4, but over 8. I was looking at the domain. So here's our function. Now we need to restrict it between pi over 4 and 3 pi over 4. So right now, if I graph it, you see the whole thing. I'm going to go back to y equal. Now to restrict it, I need to put this in parentheses. So I'm going to do second and insert, and I'm going to add a parenthesis around my function. And that's telling I'm using this whole function, and now I'm going to restrict it. So you do divided by. And then when you do divided by, we're going to open up parentheses. We're going to use this. So basically, we don't use the double-sided inequality. We got to do it one at a time. So that means normally we would write this as pi over 4 is less than or equal to x, and x is less than or equal to 3 pi over 4. So we can still do it the same way. Pi over 4 is less than x, and then we can say x is less than 3 pi over 4, but we just have to do 2 separate ones. Okay, so we'll do pi divided by 4, and then to get the inequalities, we have to do second and math to get test. Have the inequality symbols. I'm going to use number 6. Less than or equal to x, and then we have to do second test, and when we have other conditions we say and. This is the way the calculator does it. And then we're going to say x, and then second math, and then 6 again, and then we're going to do 3 pi divided by 4. All right, so just double check, make sure you got everything input correctly. Now when we hit graph, okay, you just see a smaller piece. We're going to zoom in. Let's move this cursor over a little bit. Goes too fast. If you don't get in the right spot, it'll kind of zoom in just in the middle. Won't be able to see. Okay, so this is our graph, just part of that curve, instead of saying the whole thing. All right, so from there, we can identify which curve looks the best. This goes up to a height of 2, cosine goes up to 1 unless we have a amplitude change, and we don't have an amplitude change. So between A and C, A would be correct. And just unit circle radius 1, and so A would be our best graph. All right, now we're going to compute the change in x. We can do this by hand. The difference in upper limit, 3 pi over 4 minus pi over 4 divided by n, which is 4. So this will give me 2 pi over 4. You do cube change flip, and so you'll get pi over 2, pi half times 1 over 4. So we just get pi over 8. So our sections are going to be pi over 8. All right, so once we do that, we can list the grid points, and we are starting from pi over 4. So since we are counting by pi over 8, I like to write it in terms of what we're counting by. So if I want to do a common denominator, top and bottom by 2, so pi over 4 is the same as 2 pi over 8 if you do a common denominator. So if I add pi over 8, I will be at 3 pi over 8. If I add pi over 8 again, I will be at 4 pi over 8. Now 4 pi over 8 is the same as pi halves when you reduce it. And then again, there's 4 of them. So add again 5 pi over 8. And then 6 pi over 8. And if we reduce 6 pi over 8, divide by 2, you get 3 pi over 4, which is where we want to end. So you got 1, 2, 3, 4, end was 4. So these will be our grid points. So the starting one will be pi over 4. And then 3 pi over 8. And then pi over 2. And then 5 pi over 8. And then 3 pi over 4. All right, so next we are going to illustrate left Riemann sum. So again, this is not the correct graph. It goes up to a height of 2. B looks close. So when we do left Riemann sum, we're starting our rectangle from the left and then going to the right. Go up to the height of the graph from the left, go over to the right. Left height, left height. So B looks good in that regard. This one looks like a right Riemann sum because it's hitting the graph here and then going back that way. So A and C I would eliminate because they go to a height of 2. B and D look correct, but B is going to be the left endpoint. So B is the one that illustrates the left Riemann sum. All right, now we want to illustrate the right Riemann sum. So that's kind of what we were just looking at. Again, I would get rid of the ones that go to a height of 2, so B and C. And then D would be the one that best matches the right corner point of that box touching the line and then going and making your box. Okay, so now we want to know which one underestimates and which one overestimates. Since this is a decreasing function, the left Riemann sum, as we could see up here, this is this part. Okay, left Riemann sum as you can see, goes above the box. So the first part, when it's still increasing, is below, but on the rest of it, it's above. So the left Riemann sum is going to more likely overestimate. When you get to the right Riemann sum, one little piece is above, but the rest of them are under, and a lot more is under, so it's going to underestimate. And that will change based on if the function is increasing or decreasing. Which Riemann sum underestimates and which sum overestimates. All right, so the left overestimates is what we saw. This says the left underestimates, right over, the right under, and the left over. Okay, option D. All right, we're good. And now we're going to compute the left sum and then the right sum. All right, so we're going to do that with technology because those are going to be some very finite points, and to avoid using decimals, because we are going to round the decimals at the end, we're going to do this with technology. All right, so we already have our function in the calculator. It is y1. All right, so we're going to go to math and arrow up. We get there faster. 0 is going to give us the summation. Uh-oh, I don't want that there, sorry. Delete. No. How do I get rid of that? I don't want to clear my whole equation out. Oh, it's still there. Can I delete it? There we go. All right. Second, insert, parentheses. Let's graph, make sure it's still there. Okay. Second, quit. All right, so you want to be on the home screen. Math, and go 0. All right, so now we're going to put in our indicators. So this is our variable. I wonder, did it always do x equals 1 instead of k? So k equals 1 up to 4. And then we're going to recall that equation because we're doing function of. Okay, so to call equation, we're going to go to vars, and then y-vars, and then function, and then we want option number 1 because we're doing y1, and then y1 is going to be, since we're doing the left sum, it's going to be this equation. Now we can solve this for what we need. So our xk, because it's going to change every time, it's going to be x minus 1 plus the a value times the change in x. Now the a value is the smallest value, so it's going to be pi over 4, and then plus our x value. Now they're using k, but we have x in our input, minus 1 times the change in x, which is pi over 8. So this is just the input. This is what the calculator is going to input. So it's going to, starting x equals 1, 1 minus 1 is going to be 0. So the first point it's going to count is pi over 4, which is this one. And then it will do a 2 here. So 2 minus 1 is 1. 1 times pi over 8 is this, and it'll do pi over 4 plus pi over 8, which will get us to this point. So it's going to read this formula and give us those points. Okay. So inside parentheses, I'm going to do pi divided by 4 plus, and then I'm going to open parentheses, x minus 1, close, and that's going to be times the change in x, pi divided by 8. Now, this is going to give us the height, okay? we still have to multiply by the change in x. So base times height, because we're getting the area of a rectangle. So this is the y value. We just plug that inside y of this times the height. So I have to do additional change in x. Now this is going to do all 4 of those rectangles for me, add them up all at once, and we get 1.395 rounded to 2 decimal places. That will go up, so 1.4. So for our left Riemann sum, we are getting 1.4. Okay, and it's an agreement, and now we're going to do the right Riemann sum. So again, same thing. I'm going to use technology. Now this is the formula for the right Riemann sum. I can recall this because most of it's the same. So you can recall what you just input by hitting second and enter. And that way we already have our change in the x at the back. The only thing we have to do is adjust our formula. So instead of a k minus 1, we just have k. That's the difference. We have a, we have our k times change in x. So I'm just going to arrow back into this formula, and I'm going to delete and delete. If you hit clear, it'll wipe out everything. Everything else is the same. All right, so we have our right Riemann sum, and it gives us 1.18. And you can see the difference. One is a little bit over, one is a little bit under. The actual area is somewhere in between. 1.18.